Hello and welcome to our algebra lesson for today. Algebra lesson 1-9, the very last algebra lesson before we have our test. So let's go ahead and get started. It's not too long of a lesson today. We're going to be talking about patterns, equations, and graphs. Patterns, equations, and graphs. So let's go ahead and get started with our anticipatory set. And for today, tell you a little bit about my backstory. Growing up, I had two sisters, one named Erin, one named Colleen. Erin, who is this one here, there we go, she's got nice curly hair. There we go. She is 2.5 years younger than me. So, this is me. This is Erin. And I was born in 1989. I was born in the year 1989. She was born in the year 1992. So, 1989 I was born in. So yes, I was born in the 80s. Very, very cool of me. Born in the 80s, but in 1989, she was born in 1992. And I was 2.5 years old when she was born. As we grew up, we were pretty good friends. As we grew up, we realized that sometimes we were 2 years apart. And sometimes we were 3 years apart. And I remember being a kid, we were very confused about that every once in a while we'd realize, wait a minute, I'm 7 and you're 4, that's 3 years. And then a little bit later, I'm 7, you're 5, now it's 2 years. We were always kind of confused about that. And as we got older, then we realized, obviously, 2.5 years. It's because my birthday's in July and her birthday was in February, so it was always a little strange. But no matter when, I was never 2 years older than her, and I was never 3 years older than her. I was always 2.5 years older than her. So let's go ahead and get started with today. And that's what we're talking about. All right, let's get started with our standard. And our standard today is standard A-REI.10. I thought it was kind of funny when I looked at it that don't they realize that A-REI.D.10 is the same thing as saying A-REI.D.1? Little decimal joke for you. Anyway, let's keep going. All right, our standard today says understand that the graph of an equation two variables is the set of all its solutions plotted in the coordinate plane. Often, but not always, forming a curve, which these curves are not always just curves, which could also be a line. All right, so I know we've worked with graphs before. We're going to go ahead and work with graphs once again here. So let's go ahead and get right into our input. So our input is going to focus mostly on what you can see here in the, there we go, in our standard. Our standard says, understand that the graph of an equation in two variables is the set of all its solutions plotted on the coordinate plane. Every solution. So first of all, we're going to want to make sure that we understand what a solution is. And a solution is going to be our first language of the discipline. Solution. And then we're just going to make sure that we know what this is, a solution of an equation. So we are talking about solutions here. We're also talking about solutions of an equation. What is a solution of an equation? And the solution of an equation is any ordered pair. And remember, an ordered pair is the variables x and y, just like that we've worked with before. Any ordered pair x, y that makes the equation true. Any ordered pair that makes the equation true. So let's just go with the most very basic, simple example we can have right here, which I'm just going to say is y equals x plus 1. Y equals x plus 1. That means our ordered pair needs to fit this rule. The y value needs to be the same thing as the x value except one more. So if we say, and remember, in an ordered pair, the x always goes first. If I say that the x is going to be, let's say, 2, y is going to be x plus 1. So y is going to be 3. Because the 2 is the x, 2 plus 1 gives us what the y would be. So it'd be 2 plus 1 is 3, y would be 3. All right, our next term is inductive reasoning. Inductive reasoning. And inductive reasoning is the process of reaching a conclusion based on an observed pattern. Based on an observed pattern. So if you see a pattern, you're able to then understand what's going to happen as that pattern gets longer and longer and bigger and bigger. Okay, we have just a we have just a little bit left here on the page. So I'm going to go ahead and scoot this down a bit and start our input, our details portion. So go ahead and draw your flower. And the thing we're going to be talking about during our input today, what our input's going to be based on, are ways to view relationships. And no, not those kinds of relationships. These relationships between numbers, how things react. So here we go. Let's start with tables. One way to view relationships is to view a table. So we're going to go ahead and create a table based on a relationship here real quick. And I'm going to do my absolute best to try and draw this right now. It may fail, but here we go. All right, the relationship we're going to be using is, oh boy. Okay, It's supposed to be a buffalo. Just pretend that that's a buffalo. It's got like a hair. That's not, it's not horrible. All right, I'll take it. Okay, so we have one buffalo. All right, we have one buffalo right there. But on each of these buffaloes, we have 4 hooves. 2, 3, 4. 4 hooves right there. So we can go ahead and we can put this relationship into a table. So let's go ahead and draw out a little table. Okay, up here, I'm going to go ahead and put buffalo. And down here, hooves. Doesn't really matter which one you put where, just matters that you have it there. Okay, and then let's go ahead and fill in this relationship. If I had 1 buffalo, I would have 4 hooves. If I had 2 buffaloes, I would have 8 hooves. If I had 3, so now if I had 3, I have 4, 1, 2, 3, 4, 1, 2, 3, 4, I would have 12 hooves. If I had 4 buffaloes, I would have 16 hooves. If I had 5 buffaloes, 20. So you can see we understand that relationship because you can look at a buffalo and understand, yes, a buffalo has 4 hooves. And as it goes up, it's going to increase by 4 each time because each extra buffalo is going to have 4 more hooves. So this will just go on, etc., etc., except this one's etc. times 4. Okay, so that's a table. That's us creating a table of a relationship. Let's move into, and I'm out of space here, so I'm going to go ahead and switch this out. Let's go ahead and look at another way to look at a relationship, one that we've used quite a few times before, and we're going to go ahead and put a graph. How do you use a graph to show a relationship? Well, we're going to keep the same relationship, which is our buffaloes and our hooves. And buffaloes are going to equal, we're going to say buffaloes are the X value. And we're going to say the hooves are going to be the Y value. So the buffaloes are going to be our X value, and the hooves are going to be our Y value. So let's go ahead and draw a graph. Okay, that'll probably be good. On the bottom, on the X axis, I'm going to go ahead and say that each of these are going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we're going to go by 1 on the X value, and we're going to go by 2 on the Y value. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Perfect. So now we know our buffaloes are our X value, so the buffaloes are going to be down here. And the hooves are going to be our Y value. And how are they going to relate to one another on this graph? Well, if I have 1 buffalo, I'm going to have 4 hooves. If I have 2 buffaloes, I'm going to have 8 hooves. If I have 3 buffaloes, I'm going to have 12 hooves. 4, I'll have 16. 5, I'll have 20. And we can keep going on, but we're running out of room on our graph, so we'll leave it right there. So now you can see I have a relationship drawn on my graph. Now, here's a question. I'll put my little unanswered question icon. Here's a question. Do I connect these lines or these dots? Do I use a line and connect these dots? Think about it. Look at the way the relationship's going. Think about what the relationship is. I have 1 buffalo, 2 buffaloes, 3, 4. Should I connect this line? No, I will not connect this line because the hooves and buffs must be whole numbers. We're not going to talk about half buffaloes and things like that. We're just talking about full buffaloes. Now that is different. This is unlike the ages. So the ages we were talking about in the anticipatory set, this is unlike that. Ages, every infinitesimal move that you make along your age, you are constantly the same age. So you can do that. But here, it needs to be a whole number buffalo. We're not saying we're going to have 1.2 buffaloes and 4 point whatever hoops. We're going to be very careful. You need to make sure you know what the relationship is. In this case, the relationship must be whole numbers. All right, so that's our graph. That's a way to graph something. So let's go look at our last way to look at relationships, and that's going to be through an equation. All right. And again, we're going to keep the same situation where our buffaloes are going to be our, oh, can't see that, sorry. Buffaloes are going to be our X value, and our hooves are going to be our Y value. Okay, so let's look at what the most simple explanation of this is right now. The most simple way to look at this is that if we had one buffalo, we would have 4 hooves, and that relationship stays constant. So if we're looking at this, it says Y, the Y value is always 4 times the X value. So because Y is always 4 times the X value, we can write that into an equation. Y is the same thing really as saying an equal sign, is always 4 times X. So if we look over here and we know that this is correct over here, we can say that for the ordered pair of 4, 1 is a solution because it fits into that equation. Since 1 and 4 will fit into this, Y, 4 equals 4 times 1, that's absolutely correct. So that is a solution. And we can find so many more solutions. We can find 2, 8 would be a solution. 3, 12 would be a solution. So what you do when you're using your equation is you show Y as it relates to X. Show Y as it relates to X. Y is 4 times X right here. All right, so let's go ahead and move along. That's it for our input. We're getting into our modeling. In our modeling, we're going to start out, we're going to have a couple of 3 questions here that we're going to go over. Let's go ahead and take a look at our number 1. Number 1 is the ordered pair of 2, 4, a solution of the equation Y equals X minus 2. So if we're looking at that ordered pair, is that ordered pair going to be a solution? Well, let's go take a look. First of all, you're going to go ahead and substitute. So you're going to substitute the X and the Y value. Remember, here's our X and here's our Y. You're going to substitute those values into our equation. So the first thing is our Y value is going to be 4 equals our X value is going to be 2 minus 2. Then you simplify. Now that you've substituted, you're going to simplify. 4 equals 2 minus 2 is 0. Does 4 equal 0? It does not. So 2, 4 is not a solution. And there's your answer. Okay, let's look at our next one, number 2. All right, our next one is going to be very similar, and it says, is, now we're going to go into negative here, -3, -9, a solution of the equation y equals 3x. Is that a solution? Well, we're going to do the same steps. We're going to substitute. We're going to take our x and our y values, and our y value is going to be -9 equals 3 times our x value, which is -3. Then we simplify. -9 is simplified already. This side of the equation, 3 times -3, well, I know that that's going to be, since the signs are different, it's going to be negative. 3 times 3 is 9. -9 equals -9. Yes, it does. We've checked it. Great. -3, -9 is a solution. Fantastic. All right, and we're going to just have one more. Now, this last one's going to be our most involved one, where it's going to have a lot of stuff for us to answer. So I'm going to go ahead and go on to a new page, and we'll get this last one. And what we're going to do on this last one, okay, there we go, is we are going to solve our anticipatory set. So our anticipatory set said that Mr. Berry is 2.5 years older than his sister use the table, or use a table, equation, and graph to show the relationship between their ages. How old, no, actually, I'll use her name so she doesn't get mad at me. How old was Erin? Didn't capitalize her name, she'll get mad at me for that. How old was Erin when Mr. Berry was 10? Okay, so a bit of a long equation there, and yeah, I understand, or a long question. There we go. Was. Okay, so we're looking to understand this relationship with 3 different ways: a table, an equation, and a graph. So let's go ahead and start with the table. Well, I'm going to use red as my table. So here we go. Okay, so we're using a table. So let's start. We want to know the ages. So here's Erin, who's going to be our x value. And here's Mr. Berry, who is going to be our y value. There we go. So now we have the beginnings of our table. So I'm going to extend out the table now. And now we're just going to go through and find the ages. So let's start with when Erin was 1 year old. I, Mr. Berry, am 2.5 years older than 1 right now. So 1 plus 2.5. So this is going to be 1, do up here, 1 plus 2.5 is going to give us 3.5. So when Erin was 1, Mr. Berry was 3.5. We go up when Aaron was 2. Mr. Berry was 2.5 years older than this. It's going to be 4.5. 3, 5.5. Now, you may realize that since we're talking about ages and we're going up by 1 year each time, it's just going to go up by 1 each time. So 4, and it's going to be 6.5, 5, 7.5, 6, 8.5, 7, 9.5. Okay, so we're getting pretty close to what we wanted the answer. How old was Aaron when Mr. Berry was 10? We're getting close. So now let's say 8, 10.5. Wait a minute. Now, oops, it doesn't look like it. There we go. Now we're kind of stuck here, right? We were looking for when Mr. Berry was 10, and now it just says 10.5. So as you can see, the reason we have more than one way to view a relationship is because sometimes it's not going to give us exactly the right answer. Let's go ahead and do the equation, which was second. I'm going to go ahead and let's use some light blue for my equation. So my equation, let's see if we can get the answer from the equation. So we're going to do the same thing. If we're looking up here, how did we change from here to here? Well, whenever we had the x value, we added 2.5 to it. So y is going to equal x, whatever x was, plus an extra 2.5. So now we're going to go ahead and simplify, or we're going to input what we want to know. So we know that we want to know when Mr. Berry was 10. Mr. Berry is the y value, so we're going to say 10, because that's what we want to know, equals x plus 2.5. Now, we need to find what is the value of x. We're trying to find x. Now, the best and easiest way to do this would be to subtract 2.5 on this side, which would cancel that out, and subtract 2.5 on this side. Then we would just have to find what 10 minus 2.5 was. Now we can also switch that. Since you are smart 8th graders, you know that a half means 0.5. So you can say 10.0 minus 2.5. Can't do that. So we're going to go 0, 10 here. We're going to do 9, 10 here. 5, 9 minus 2, 7. Drop the decimal point, 7.5. We can go ahead and convert that back to a fraction. So x is now going to equal 7.5. So Aaron was 7.5 years old. So when Mr. Berry was 10, Aaron was 7.5. Okay, and let's get our last one. And for our last one, I'm going to go ahead and use, let's say, I'm going to use some orange there for our graph. Let's do the last way of looking at a relationship. We're going to need to go ahead and draw our graph. There we go. I guess we can move hers out a little bit more. The x value on the bottom, we're going to go by 1. We'll go by 1 on both sides. So this is by 1, this is by 1. Okay, so this is 2, 3, 4, 5, 6, and this is Mr. Berry. On the y-axis, I'm so sorry, you couldn't see any of that. And this is Aaron on the x-axis, 2, 3, 4, 5, 6, 7, 8, 9, 10, blah, blah, blah. Okay, so let's go ahead and fill in what we know. When Aaron was 1, Mr. Berry was 3.5. Okay, let's get our first one down. 1, Aaron was 1, Mr. Berry was 1, 2, 3.5. There we go. When Aaron was 2, Mr. Berry was 4.5. And you can see that there's going to be a pattern starting right here and moving its way up this way. So we can continue that on and on and on. It's still continuing to this day. It's putting more and more data on the chart. So let's go ahead and find out what we want to know. If this is 2 and this is 3, 4, 5, 6, 7, 8, 9. Okay. So when Mr. Berry was 10, Aaron was how old? 3, 4, 5, 6, 7, 8, 9, 10, on and on and on. Okay, so let's keep this chart going a little bit further. Same pattern. And now we're going to look. So I'm just going to trace 10 over. Oh, but there's no dot there. But since this is, look at the relationship of this, the ages, can we connect these lines? Absolutely. Because even when Aaron was 1 and 1 month, I would be a little bit further on that line. So this is going to be something we can connect with a line. And now you can see that we attach that line right there. And Aaron's going to be 7.5, halfway between the 7 and the 8. So Aaron was 7.5 years old. Excellent. So that is the way to graph. That is the way to graph and use an equation and use a table to get your answers. Let's go ahead and figure out what our guided practice is going to be. Guided practice will be our PPSE, which is in the book, number 9 through 25 odd. And our independent practice remember, we have a new, more efficient way of doing this, which is going to be the assigned 1-9 quiz. And those are your guided practice and your independent practice. Good luck, have fun, and remember, after this assignment, you have a review day tomorrow, and the next day you will take your topic or your chapter 1 test. So make sure you are ready for that, and you are reviewing your notes, and you're taking advantage of the review materials. All right, have a great day and go Buffs.